So what we're going to do now, we're going to look at how to do a force analysis on an object in SHM. Now, remember that SHM is essentially still mechanics. So let's consider a vertical spring, okay, like so. And we must remember that at this equilibrium position over here, okay, the weight of this mass, let's call it mg, has to equal to the spring force, let's call that Ke, where E is the extension of the spring at equilibrium, like so. Now, if we want to prove whether something is in SHM, we need an expression for its acceleration, and we must show that this acceleration equals to negative omega squared x, or at least show that A is directly proportional to x in a more general form. And so let's consider this spring or this mass at some displacement x below equilibrium. And in such a case, what will be the forces acting on him? There will be, of course, his weight mg, and there will be this spring force over here, which will be Ke plus x. Okay? And so let's form an equation, right? If we know that this is an SHM, then of course the net force has to be pointing this way, MA. Okay, and so we can have something like this. Ke plus x minus mg must provide MA. And so we see we are simply doing a force analysis. And so since we know that mg equals to Ke, then when we expand this bracket over here, Ke becomes mg plus kx minus mg equals to ma. And of course, very nicely, the two mg's will go away. And so we have kx equals to ma. And so a equals to k over mx. Now, since both k, the spring constant, and m, the mass of the spring, is constants, this means a is indeed directly proportional to x. And so we have shown that a vertical spring oscillates in simple harmonic motion if there are no dissipative forces. Now, I can take this, or rather I can find something quite cool from this. Basically, when you look at k over m over here, okay, this is of course equal to omega squared. And so we get a very nice relationship here. So for spring oscillations or spring SHMs, omega, their angular frequency, is equal to the square roots of k over m. And so by making some manipulation, we can also get a very nice expression here where the period of a spring SHM is equal to 2 pi square root m over k.